Hi, everyone. Thanks for joining. If you can hear me and see me, we're going to get started soon. If you could place in the chat where you're tuning in from, I'd love to hear you introduce yourself. Tell me where you're from. Hello, everyone. Thanks for coming. 9:10. We're going to get started in a couple seconds. If you could place in the chat, introduce yourself and let me know where you're from. We'll get started here shortly. Hello, everyone. Thanks for attending. It looks like it's 9:10. We'll wait just a couple seconds before I get started. Let everyone come in. If you could let me know where you're tuning in from. We'll get started here in just a couple of seconds. For myself, I am coming to you from Los Angeles, California. Thanks, Christian. All right, just gonna get started in a couple seconds here. All right, let's do it. So thanks everyone for coming, and thanks DataOps Unleashed for having me. My name is Nick Acosta, and I'm a developer advocate at Fivetran. And we're going to be looking at DataOps automation and orchestration with Fivetran, DBT, and the modern data stack. Going to be providing a demonstration how the modern data stack can be added to your DataOps practices and the benefits of doing so. So at Fivetran, we've been surveying data companies and found a high rate of resource waste on pipelines, with 52% of companies that we surveyed utilizing 11 or more data sources in their DataOps process. But 92% of the analysts in those organizations performing data integration tasks or tasks outside the scope of their role. 90% of analysts report several data sources being unreliable, and 68% of analysts say that they lack the time to implement profit-driving ideas. This resource waste is because data pipelines are manual and brittle. So after identifying sources and defining schema, many organizations build out custom Python ELT tasks, but when schemas change or new data is needed, reports can break down and they have to be patched. And when this is happening individually for every pipeline, similar ingestion tasks have to be re-engineered, pipelines have to be rebuilt over and over, and data integration becomes the bottleneck. So if a new user or a new requirement comes from an end user, that can create a chain of dependencies that can be traced all the way back to an ETL tool and the sources it's pulling from. But this data integration bottleneck can be resolved by automating data integration, and that's exactly what we're doing at Fivetran. So Fivetran is automated, and it creates and maintains a perfect replica of your data with minimal user intervention across over 150 different data sources. It's resilient, and the core architecture of Fivetran enables recovery from any point of failure with no user intervention. It's cloud native as well, so our engineers are monitoring and updating our code as sources change. So with Fivetran, you log into the source generating data, maybe the transactional database that's storing data. You log into the data warehouse where you'd like that data to go. and Fivetran does the rest. Does so fully managed with no configuration. And this approach has a number of benefits. So when new data is pushed to a warehouse, it's done so automatically with automatic data updates. Changes in schema from sources are automatically captured and migrated. And data deduplication is managed on failure, so making the resulting tables in a warehouse idempotent. And all of this can be managed in the Fivetran UI, but we'll see an example of how it can be extended via orchestration tools and APIs as well. Fivetran plays a part in a larger modern data stack. And I've talked about its ability to perform automated data ingestion. And only after that happens, once data is in a warehouse in its raw normalized format, will transformations occur. So this is a shift from ETL, extract, transform, load approach spent re-engineering brittle data pipelines to ELT. And those transformations happening only after data has been extracted and loaded into a warehouse. These transformations can happen in the warehouse with an open source project called DBT, which this is DBT's logo here, and we'll see it later in the demonstration. DBT stands for Data Build Tool, and it's bringing software development best practices like version control to data analysts by performing transformations in SQL in the warehouse. We saw earlier that a majority of companies have more than 11 sources in their DataOps process. As the number of data pipelines in your modern data stack scale, or your use cases change, you may benefit from an additional tool to manage this process, manage the execution of tasks that make up your pipeline. At Fivetran, we collectively refer to these tools as orchestration tools. And 3 popular open source projects in this space are Airflow, Prefect, and Dagster. I'm going to walk through a diagram of how one of these tools can be set up with Fivetran and DBT, then demonstrate that architecture in action. But first, I'd like to illustrate some of the main reasons why developers are using this type of setup. So here are the 3 main reasons I'm seeing Fivetran users orchestrate their modern data stack. The first would be synchronizing syncs. So orchestration tools allow you to have a very fine-grained control over when things happen, and they improve the awareness on tasks that comprise these pipelines, their dependencies, and their execution. So this enables what you're about to see demonstrated, and that is performing data transformations across incoming data sources. You can prioritize data syncs as well. So maybe you're bringing in more data than your warehouse can concurrently handle. Or maybe there's important financial data that you want pushed to the warehouse first. You have jobs that you know are going to take a long time to get all the way in the warehouse that you want performed first, or maybe you want to put those off until last. You just have that fine-grained control over when things happen. And if you're orchestrating ELT with Fivetran, you're still receiving all the qualities that make Fivetran different. I'll show how and why in the demonstration, but you're inheriting the benefits of automated data integration as well. So this is where we're seeing that DataOps automation and orchestration both happen at the same time. This synchronization of data syncs allows you to trigger transformations on that data based upon its presence of new data in your warehouse. So this is important because if transformations happen too late after the data's already landed in the warehouse, that can cause latency problems that can affect SLAs. But transformations that are performed too early can overlap with data ingestion jobs, which can cause missing data or integrity issues. Finally, I'm seeing people like to use Fivetran with an orchestration tool because orchestration tools allow your DataOps process to be managed from a single tool. So that includes both Fivetran and DBT, as well as data tasks that are happening before data comes into Fivetran and tasks that happen after data is transformed by DBT. This allows different data teams to collaboratively integrate their work into a pipeline without acute knowledge of the whole pipeline. So a data engineer can build data models without knowing how a data scientist is building machine learning models and vice versa. We saw at the beginning here that 92% of data analysts perform work outside their job function, so an orchestration tool can help alleviate that. Here's what's going to be happening in the demonstration. I'm going to be bringing in data from two different sources via two connectors through Fivetran and into a data warehouse. As soon as the data arrives in the warehouse via Fivetran, it's transformed by Fivetran's DBT ad reporting package, which you can find, and I'll show later, at hub.getdbt.com. But this transformation package contains SQL that can be used with DBT that allows you to track ad clicks, ad impressions, and ad spend in the same campaigns across multiple different sources in a single modeled table. So you can see LinkedIn and Twitter here, but the package also supports Facebook, Google, Microsoft, and Pinterest as well. And you can customize it or build on top of it as you would like. I've customized my version of the ad reporting package to just handle LinkedIn and Twitter for this demonstration. So we have the two Fivetran jobs in the DBT job transfer. The two Fivetran jobs are bringing in data, the DBT job transforming it after. That comprise three jobs that define this data pipeline. An orchestration tool, in this case Airflow, starts and manages the execution of these tasks. And you could call this particular setup a GCP implementation of an orchestrating ELT architecture, because as you'll see in the demonstration, I'm using Composer, which is GCP's managed Airflow offering, BigQuery, which is GCP's data warehouse, and Compute Engine, which is GCP's virtual machine service. But this architecture is generally very flexible. There's a number of different ways that you can host DBT, or you can have people manage it for you. This architecture, I'm showing it with GCP, but it still works very well with other cloud data warehouses like Snowflake and Redshift. And just like DBT, there's a number of different ways that you can, and places that you can host Airflow, or you can have service manage it for you. But let's take a look at this architecture in action. So here you can see Fivetran on my screen. Again, Fivetran is moving data between sources that are generating it, or maybe transactional databases that are storing it, into data warehouses like BigQuery. So all I do is place my destination and source credentials in Fivetran, and it does the rest. Fivetran defines the relationship between sources and destinations as connectors. And all I need to do to manage a Fivetran job inside Airflow is copy its connector ID and paste it into Airflow. So for each connector, for this one, it's bringing Twitter ads data into BigQuery. I have a Fivetran connector ID, which I can copy and then paste into Airflow. So this is Airflow. I'm running it on GCP via their service Composer. After I copy and paste that connector ID, then I can manage my Fivetran jobs here. So Airflow facilitates the organization and execution of not just Fivetran, but the other data tasks that I might have in my pipeline and their dependencies between each other. So the data is being manipulated here outside of Airflow, right? The Fivetran tasks, which I can see here, are these two blue boxes. Those are both running in Fivetran. The DBT task, this white box, is happening in a virtual machine. Airflow is just showing and managing how they work together. It does this in something called a directed acyclic graph, or a DAG. And with almost no code, I can organize the makeup of my DAG, the tasks that are in it, and their dependencies between each other. So this is the DAG that I'm running in Airflow. I can see the Python code that I have written to perform this DAG. So with a single line, I'm performing data ingestion through Fivetran just by referencing those connector IDs that I copy and pasted into Airflow earlier. And I'm running them, I'm copy and pasting them into a Fivetran operator that we've built here at Fivetran with the help of Astronomer that does the execution and manages and monitors a Fivetran job, again, just by specifying which job I wanted to run and manage. And we're already seeing some developers utilize a Fivetran operator in Airflow, but many more are writing custom Python jobs that are really difficult to scale. So if you're managing 70 different data workflows in Airflow, there's a lot of opportunities for things to break. And if they're breaking at the data ingestion stage, they're breaking down before things can really get started. So you can imagine that maybe Twitter changes their API and you get a Datadog alert that pipeline 40 out of 70 is broken. You have to crawl through and see which API call changed in Twitter and led to which table breaking, which messed up what type of transformation that broke this particular dashboard, right? That same chain of dependencies that we saw earlier, the same manual and brittle situation I referenced at the beginning. Fivetran, again, is alleviating this by automatically capturing those data updates and schema migrations. Here, with the Fivetran operator doing so with just one line of code for each connector. It takes one more line to define the relationship between Fivetran and the rest of the data pipeline, the rest of the DAG. So I have here just a single place for all of my DataOps management. In this case, the rest of my data pipeline is just a single DBT job, a single data transformation. Here I have DBT halting until both LinkedIn and Twitter are done, until Fivetran's done syncing both of those data sources into BigQuery. But it's just as easy to have DBT run every time there's new data in the warehouse. So when I could easily change this to have it when Fivetran is syncing either LinkedIn or Twitter, so it's super flexible. If I go back to Airflow, each of these tasks operate in an independent runtime. And since the Fivetran jobs have no dependencies, they start immediately and at the same time. So if I look at the fourth row from the top where it says started for this task, the Twitter job started at 22 seconds after midnight, and the LinkedIn job started at 13 seconds after midnight. So this is allowing me to synchronize those Fivetran jobs together. We can take a look at what's happening in Fivetran. Again, this is the Fivetran UI, and I can see that I manually triggered that update. I started syncing data from Twitter into BigQuery at midnight, and I can get some information about the data syncs that Fivetran is providing, how long they took, how much data they pushed to BigQuery, things like that here in Fivetran. So I can monitor the status of Fivetran jobs here, or I can in Airflow as well via that Airflow operator. So each of these tasks is going to have their own separate logs, And I can see now the Fivetran operator in Airflow connecting to my Fivetran instance, identifying the right connector via that connector ID that I copy and pasted into here, starting that sync again a couple seconds after midnight, and then pulling the status of Fivetran being able to push that data through Twitter into BigQuery. Once Fivetran is finished, then I'm able to finish this task and relieve its dependency on the things that are happening further downstream. In this case, it's just that last DBT job, which has two dependencies, those two Fivetran tasks. Once they are both done, DBT starts. So I can see that the Twitter ads took 20 minutes, it finished 20 minutes. You see the ended row 5 from the top. Right below started this finished 20 minutes after midnight. The LinkedIn ads connector took longer. It finished at 2:40 at night. So once it's done at 2:40, the DBT transformations, my data transformations happened, I think 17 seconds later at 2:41. So now I've successfully triggered those transformations, right? As soon as all of the data that I need for this transformation is in the warehouse, Airflow allows it to run. We can take a look at that DBT package a little bit more closely at hub.getdbt.com. So this ad reporting package aggregates and models data from multiple Fivetran advertising connectors. The package standardizes the schema from various ad connectors and creates a single reporting model for all activity, allowing you to analyze your ad spend, clicks, and impressions across campaigns, ad groups, and parameters. So this is a DBT package that was prepared and contributed by Fivetran. It is a milestone for us because it is our first ads package, or first DBT package that we have contributed that goes across different sources. Those 6 of which are here, aggregating those together in a single table that'll allow you to track campaigns across these ad platforms. And in doing so, modeling data across different incoming data sources lends itself really well to Airflow. I don't really see a way to effectively be able to run these DBT transformations unless you have knowledge of when everything is happening, unless you're able to synchronize these various ad sources, synchronize their data syncs in a warehouse, and being able to trigger them after. If you don't do that, it's going to lead to those situations that I talked about where you're either having latency issues or data integrity issues. But this isn't the only package that Fivetran has contributed to DBT. You can see many more at hub.getdbt.com/Fivetran. We can take a look at the output of this ad reporting package, the transformations it's making, the new tables that it's creating, and the data that it's moving to those tables in the log for the DBT transformation. So I can get some information on what's happening, what transformations, and how much data it's pushing into DBT. So I can get some information where we saw the LinkedIn ads connector is taking much longer than the Twitter ads connector, but that's because it's pushing much more data through. So I've successfully triggered that transformation as soon as all of the data that I need for it is in a warehouse. But I can also, create, run, and schedule everything that I just did all within the Fivetran UI, right? Many people do because it provides things like automatic data updates, change data capture, and idempotence. But if we go back to the slides and review, there are a couple additional things that I'm gaining by running Fivetran through an orchestration tool. So integrating the modern data stack and ELT into your DataOps processes into your orchestration tools, it allows you to synchronize your syncs, trigger transformations, and manage your entire DataOps process. And you can do so today with Fivetran integrations that are available in both Prefect and Airflow. And if you have any questions about these integrations and how to add that Fivetran operator to your Airflow environment, or how to do the same thing in Prefect, if you have any questions about Fivetran in general, please let me know. I can take some questions here as well. But I wanted to, before I wrapped up and take questions, I wanted to thank you all again for coming, and thanks DataOps for having me. Thanks DataOps Unleashed for having me. So let me see if I can get into this Q&A and see if I have any questions. Looks like I am going through the chat here. If you do have any questions, please let me know. But it looks like we are all set. So again, my name is Nick Acosta, and this has been DataOps Automation and Orchestration with Fivetran, DBT, and the Modern Data Stack. Thanks again for coming, and I hope you enjoy the rest of the conference.